I thought it's probably time that we make a quick document on how to install and upgrade and give more functionality to all the modules that we've already released. There's plenty of people that have purchased them, but a lot of them might not be running the most up-to-date software, so I think it's a good idea just now just to go through how easy it is just to set them up, and you can ultimately customize them to suit whatever you want. So this document gives you a really step-by-step guide. We'll go through, we'll download Arduino IDE, we'll install the boards that we need to do, we'll set the boards up. If you've got a Haldex controller, we'll set up the Teensy, we'll download all the libraries we need, and then ultimately we'll go on to configuring the firmware. It's not a particularly lengthy document. You can see here there's not a lot of text, it's a lot of pictures. So I'll jump in. Let's say this is a brand new computer, we've not done this before. We're going to Google for Arduino IDE, and we will go on here just now, and we will download the most recent version. So there's no point in me downloading it and installing it, but let's say that we've now installed it, and we've opened up Arduino IDE for the first time. You will now be presented with something like this. Blank Arduino, never used it before, right? Next stage for us, predominantly all our products will either use the Teensy or, for the Haldex controller, or they'll use an ESP. So we need to configure them under your boards manager. Now, straight off the bat, the Arduino IDE is primarily for Arduinos, so ESP and Teensy aren't included, and we need to add them in. So we'll go to File, we'll go to Preferences, and you want to put in these links here. These are stored in the text document. This allows the Arduino IDE to go and capture or to go and get what these boards look like because it's never seen them before. So it's one item for each line. You can copy and paste that from the text document and then add that in there. That's the boards added. You'll then go to Boards and you'll type in ESP32 and you'll install the ESP32 by clicking on this button here. ESP32, and you'll install the Espressif Systems ESP32. Now, the current version is 3.13, and there's been a lot of issues with this revision, so I've left it at 2.0.17, and you can just choose to downgrade to this version. You can see here it will install. Just now you can then go back and you can downgrade to this. Once you've installed that, that's your ESPs installed, you're good to go. Same for your Teensy, that doesn't matter for revisions, and then that's your boards for your Arduino IDE installed. Next thing for us, we use quite a lot of libraries. It's a much easier way of being able to get common functions. So if I'll just change this back to why is Chrome not showing up? There we go. So if we go to GitHub and we go to my own GitHub, go to repositories, and these are all of the products that we've got, all of the softwares on here for the most recent version. Every so often I will start to use a new library, but for the most part everything's in here. This is the bulk of all the kind of heavy lifting, if you'd like. So if you open up the libraries, go to Code, go to Download, and that will download in there. Once you've downloaded it, you can then extract it. Now that will always go into your Arduino folder. So you can see these are all the projects that I've been working on in the background, stuff that I've written that I don't always use, or that kind of thing. It's predominantly in your Documents folder under Arduino once the Arduino IDE is installed, and there will be a Libraries folder. If you've installed it and you've never used it before, there might not be a Libraries folder yet, so just create that single folder, Libraries, and then all of the files that you've extracted or downloaded, extract them into this location here, and you should have a replica of this. These are all the libraries that I've used in the past. Rather than pick out the ones that are appropriate for each module, it gets quite bitty, so I've just given you a copy of everything that I've ever used. For the speed pulsar, we've got the fast PWM, we've got CAN libraries for Teensy, we've got LIN controller libraries, we've got LCD menu libraries, stuff like that. So once you've extracted all of your libraries, you're good to go. You can now start downloading the source code for whatever product you want to look to update. So for example, if we go back to the GitHub, let's pick Cancluster. Or actually, let's pick the speed pulsar, because that one seems really popular just now. Go into speed pulsar. That was updated 5 days ago. The code was updated 51 minutes ago. So you can download the PCBs, you can build them yourself, you can print off supports, there are the models if you want, and predominantly if you download the code, go into code, you can download this, and then once it's downloaded, exactly the same as before, you're going to want to extract it into your Arduino folder. Now before, you had all of your libraries put into the library folder. All of the code that you want to be working on is one up, so it's in this area in here. So I've got a folder called Cancluster, and then these are all the files in here. Now Arduino wants to see this folder name having the same title as this. So if you just stick it in a generic folder, it will ask you if you then want to move it. You can say yes, but you'll need to move all these files in with it. Once you've moved it, you can then open it up, which looks something like this. So we've now opened up this Cancluster. Just to give you a breakdown of the code, just so there's a bit of revision history up here. You can see as we've progressed through what changes we've made. There's a little bit of CAN. Ultimately you're going to get CAN. There might be GPS depending on setup, and then buttons for DSG paddles, and then there's a couple of spare buttons as well. Really the whole Cancluster thing is it wants to pulse RPM at a frequency, and it wants to pulse speed at a frequency. So that's these timers here which tick every X time, whatever we tell it to tick at. And then you come in here, basic init, set up your pins, get everything ready. If you've got needle sweep turned on, let's do needle sweep. And then you come in here, if you've got an engine management light, turn it on. If you've got an EPC light, turn it on. Calculate your speed. So there's multiple options for speed here. So you've got, you can get it directly from the ECU, you can get it from DSG, you can get it from GPS or ABS as well if you've got ABS. Set your shift lights, and then set your final speed in here. People are only really going to be interested in the defs file here, and all of our software has a defs file. Typically at the start I always put in your kind of on and offs. Do you want to see stereo data? Do you want to perform self-test functions? Is there something not right with the module, or do you want to make sure all the outputs work? I just keep that in there. So once it's released I turn that to 0, but during my testing elements I'll leave that as 1. Have you got a Mark II coil? Is that what you're using it to drive, or are you driving a Mark III one? Do you want needle sweep on or off? That's a 1 or a 0. What type of speed have you got? Again, the comments in here explain what you can be doing. So if it's 0, you'll get it from the ECU. If it's 1, get it from DSG. And then what speed units you've got. If you've got needle sweep, how quickly does it sweep around that cluster? So this is currently 5 milliseconds between sweeps. If you want to make it longer, increase that number. If you want to make it shorter, decrease the number. These are your hard limits. These will be cluster dependent. Some clusters will want to see less frequency for more speed. Some will want to see more frequency for more speed. So this is your really fine tuning of your speed and your RPM in here. If your cluster is set to a higher limit, you'll also want to increase that as well in conjunction with this. if you're using the shift light, so if you want it to pulse the EML or the EPC as a shift light, you can set what shift limit you want. These are for how quickly each gauge wraps round that cluster. So if you're finding that the RPM gauge goes faster than the speed gauge, you'll want to decrease this number or increase this number. You can play about with them to get that sweep perfect. You'll never need to change the pins, they're set in hardware. And then anything after that you're not interested in. So once you've set up, predominantly all you'll be really interested in is these features in here, and it's just ones or zeros, or depending on your delays. Once you've got it set up, in this case it uses an ESP, and you'll want to plug your Cancluster in, and you'll want to choose what type of module you've got. So all of ours use a dev kit, so click on this, click on select other port and type in dev kit, choose the board, and if it's plugged in it should be recognised as whatever COM port it is. This machine's got quite a lot of USB ports, so the number's quite high, but I would traditionally expect everybody else's to be quite low. So just click on that, click OK, and this is now bold. So just as an example, I'll unplug it just now and it's no longer connected, so it's no longer bold. If I plug it back in, it goes bold, and you can see here we're getting serial data because I've already programmed it. But once you're happy with the setup that you've got and the numbers are quite happy, you can click this plus here. That will compile the code. You should get no errors, and if you get no errors it will then upload it to the board, and that's it complete. The same process applies for anything else. You download the source code. Once you've got the board set up and you've got the device plugged in, you'll download the source code, tweak the source code to whatever setup you've got. Some might need the numbers increasing, some might need them decreasing. Just tweak them, get used to how they react, and that's it, done there. So if I clear this and restart the module, you can see here it sets up the pins, sets up the CAN chip, starts the needle sweep, finishes the needle sweep. You might want that needle sweep to go a little bit slower, so let's increase this. Let's make that, we'll make it 100 for example, because you can see that jumped between starting and finishing quite quickly. This will slow it right down, gives you an idea of just what the small changes do. I tend to put comments about can change this, so that's to give you a kind of prompt to say these features can be changed if you'd like to. Let that compile. Connects, writes to the ESP, and we'll reset this just now. Start needle sweep. See it's taking much longer. So that's currently pulsing through each of the RPMs, ultimately to try and get to this max speed limit, or the cluster, the limit, and each of them will move at this rate. So it is considerably slower. You can see that it will eventually say finished. 100 milliseconds is quite a slow change. While that's going on, we'll just go through, I'll go back onto the other libraries. There we go, finished, that's it, finished now. So it does take considerably longer to get through that. We'll leave it at 5. But that gives you the concept. These will be the bulk you want to ever want to play about with. I'm going to open up the speed pulser as well, because people like to, that one's quite popular. So we'll go into Explorer, download the source code, stick it into its own folder. It's quite a simple module, this one. So we'll just go through this one quickly as well. Okay, so once you've opened it up, gives you a little bit of a kind of brief on it. Ultimately, it's reading the frequency that's coming in from your hall sensor, and it's turning that frequency into a final motor speed. I've left it as two types because the frequency that Cancluster spits out, I'd quite like to maintain in Cancluster. Some people will want to change the hall sensor, so I've left that as two different speed inputs. Similarly, you go back into defs, there's really not a lot to define. All of the kind of serial debug, do you get information back on the serial monitor? Do you want to test it? It's on the bench, that kind of thing. The motors don't change. Really, all you'll be interested in is changing your incoming type. So is it Cancluster or is it a hall sensor? So just now I want to be working on the hall sensor, so I've left that as 1. And then these are your factors. If you're playing with the hall sensor, what is the multiplication of the incoming frequency? So just now this is set to 1, so for every 1 hertz, that'll be 1 kilometre an hour. You might find that's not enough, so you might want to change that to 1.23, 1.5, 2, anything like that. And you want to massage this figure here until you get the right range of speed. What I've found is there are hard limits that the motor doesn't want to run at. So although if you put in 1% duty cycle in the motor, it doesn't actually spin. So the minimum is typically 13, and anything after 94% duty, the motor doesn't spin any faster. So what I'm trying to do there is create a window where the motor's actually working, because there'll be a dead band between 0 and 13, and then 94 and 100. So there's no point in having it operating in that region. So these are the only two factors that you want to be adjusting if you're ever playing with Cancluster, and that is pretty much it. So get it downloading, get it set up, let me know how you got on.